Yes, good morning to all. Can you hear me?
Yes, sir.
Okay, I will start. So in the previous period, we have completed topic thermodynamics first. And I have given as I have given the online test. So you have solved the online test. Yes.
Yes, sir.
So many students have solved, but most of the students have not solved that online test. So please solve these online tests. This is important because such type of problems may be asked in the examination. Okay, so now the second topic, we are starting second topic today, and its name is, that is a thermodynamics second. That is next part of that thermodynamics, and our university has given the name of that topic as thermodynamics second. Now in thermodynamics first, we have seen that is a concept regarding first law of thermodynamics. Now in thermodynamics second, that is we have to deal with, that is second law of thermodynamics. Second law of thermodynamics. Now we see first, that is why there is need for the second law. फर्स्ट लॉ तो था, हमने इसके स्टेटमेंट बहुत सारे देखे हैं, एंड फर्स्ट लॉ इज जनरली रिलेटेड विद, दैट इज द एनर्जी, एंड मॉडिफाइड लॉ इज मास एंड एनर्जी. So again, then there is need of the second law. So why there is the need for the second law? Now we see here, that is why there is a need for the second law. Now, so certain points are there, we see one by one. During the isothermal process, internal energy change of the system is zero. We have seen that is isothermal process, a process in which temperature of the system remains constant, and in this process internal energy is also zero. So during the isothermal process, internal energy change of the system is zero, which indicate that total amount of energy absorbed by the system is converted into work completely. So this indicates that is a total amount of energy absorbed by the system is converted into work completely. That is a But this is not possible for continuous expansion of gas. But it is not possible for continuous expansion of gas, as gas expands by absorbing the energy. Its pressure decreases and reaches to ambient condition, beyond which the further reduction is not possible. This means that is a system cannot produce continuous work. So this is the first point, that is during isothermal process internal energy change of system is zero, which indicate that total amount of energy absorbed by the system is converted into completely work. But this is not possible for continuous expansion of, that is, gas. For this reason, that is there is need for the second law. Now second point, according to first law, one form of energy can be converted into another form. We have seen that is energy is the capacity to do work, and it is that is one form of energy can be converted into another form. That is according to first law, that is energy neither be created nor be destroyed, but one form of energy can be converted into, that is another form, that is mechanical energy is converted into chemical energy, and chemical energy is converted into mechanical energy. That is, these energies are interconvertible. So according to first law, one form of energy can be converted into another form, but it cannot reveal that heat can only flow from hot body to cold body. That is, generally heat flow from hot body to, that is, the cold body, and not in the reverse way, and not in the reverse way. According to first law, that is energies are interconvertible, that is heat energies, mechanical energy is converted into chemical energy, or chemical energy is converted into mechanical energy. But that is if we take here heat always flows from, that is hot body to cold body, and not in the reverse body. That is heat does not flow from cold body to, that is to hot body. So it always flow from hot body to, that is the cold body, and it not in a reverse way. So this cannot be explained by first law. So there is the need for the second law. Hence, direction of process cannot be predicted by using only first law. So that is whether the heat flow from hot body to cold body, or it does not reverse by this way. That is, hence direction of process cannot be predicted by using only first law. This is the second point. Now third, these points are not so important. They cannot be asked in the examination. So you remember, only read it. Important is the statements of the second law. So only you remember this, that is the formulas. The first law does not explain, third point, the first law does not explain why chemical reaction does not proceed to completion. The first law cannot explain, that is chemical reaction do not go to completion. This can be explained on the basis of second law of thermodynamics. This is the, that is third point. The first law does not explain why chemical reaction does not proceed to completion, and this can be explained on the basis of second law of thermodynamics. Next 4 point, if two bodies A and B are capable of exchanging heat, are brought in contact with each other, first law will fail. Simply you have to see, listen the lecture. You don't write anything on the ASEM. You are writing. Otherwise, I will remove you. So, if two bodies A and B are capable of exchanging heat, are brought in contact with each other, first law will fail to predict whether heat will be lost by A or B. It will simply tell us that if one of them loses some amount of heat, the other will gain same amount of heat. That is, if two bodies A and B are there, and these are, that is, capable of exchanging heat, are brought in contact with each other, first law will fail predict whether the heat will be lost by A or B. So it will simply, that is, tell us that if one of them loses some amount of heat, the other will gain same amount of heat. That is first law. That is, if two bodies are there and they are capable of exchanging heat when they are brought in contact with each other, then what first law says? First law fail to predict, that is, why heat will be lost by A or B. Simply, it tells us that one of them loses some amount of heat, either A or B. Either A or B lose some amount of heat, and other will gain same amount of, and other, when A will lose heat, then B will gain that heat, or when B will lose heat, then A will gain it. So it actually do not say that A is that is losing the heat and B is accepting, either A or B. So in order to predict the direction of flow, we need the knowledge of some other criteria beyond first law. This criteria is provided by the second law. So this is the four concept. Next. Now that is important. So the first point, need of the second law, that point is not so important because question is not on that bit in the examination. Now the next part is, that is very important, that is statements of second law of thermodynamics. Statements of second law of thermodynamics. जिस तरह से हमने फर्स्ट लॉ के स्टेटमेंट देखे हैं, that is different statements of first law of thermodynamics. So similar is that is statements of the second law of thermodynamics. So different scientist has given, that is the different statements. Now we see one by one. So first is Kelvin-Planck statement. Kelvin-Planck statement. What is that statement? It is impossible to devise a cyclically operating system. The sole effect means whole effect, of which is to absorb energy in the form of heat from a single thermal reservoir and to deliver an equivalent amount of work. So this is the statement of Kelvin-Planck statement. I will repeat again, that is, it is impossible to devise a cyclically operating system, the sole effect of which is to absorb energy in the form of heat from a single thermal reservoir and to deliver an equivalent amount of work. Now, second statement, that is second statement of second law of thermodynamics, is Clausius statement. Clausius statement. So what is that statement? It is impossible to devise a cyclically operating system, the sole effect of which is to transfer energy in the form of heat from a low temperature body to high temperature body. This is the Clausius statement. That is, it is impossible to devise a cyclically operating system, the sole effect of which is to transfer energy in the form of heat from a low temperature body to high temperature body. Third statement, that is all reversible Carnot cycle. All reversible Carnot cycle operating between the same initial and final temperature. All reversible Carnot cycle operating between the same initial and final temperature must have the same efficiency. Must have the same efficiency. So all reversible Carnot cycle operating between the same initial and final temperature must have the same efficiency. Fourth point, heat cannot flow spontaneously from that is cold body to hot body. As already we have seen, that is the heat always flow from that is hot body to cold body. So it does not reverse. So that is statement is there. Heat cannot flow spontaneously from cold body to hot body. Next, entropy of the universe always increases. So entropy of the universe always increases. Entropy, this concept so in thermodynamic first we have seen the concept of enthalpy. Enthalpy, that is heat content, that is denoted by capital H. We have seen in first law of thermodynamics. So in the second law of thermodynamics, we have to see the concept of entropy, entropy, that is very important. We have to see in second law of thermodynamics. It is also that is a type of heat content. It is also a type of heat content. Entropy of the universe always increases. Fifth point, see here, entropy. Entropy, it is total heat content of the system. We see in detail that is the what is mean by that is entropy later on. जिस तरह से हमने फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स में एंथैल्पी देखे हैं, एंथैल्पी दैट इज इट इज आल्सो ए टोटल हीट कंटेंट ऑफ द सिस्टम डिनोटेड बाय कैपिटल एस. उसी तरह आपको यहाँ पर सेकेंड लॉ ऑफ थर्मोडायनेमिक्स, सेकेंड लॉ ऑफ थर्मोडायनेमिक्स में आपको एंट्रोपी कंसेप्ट देखना है. एंट्रोपी, entropy is denoted by capital S. Remember that. We see later on that is entropy. What is entropy and its significance? So fifth point is that entropy of the universe always increases. Now next sixth point, an isothermal process whose only result is the conversion of heat into work is impossible. There is isothermal process we have seen, that is a temperature remains constant, internal energy is zero. So an isothermal process whose only result is the conversion of heat into work is impossible. Seventh point, the maximum work obtained from an isothermal process is a function only of the initial and final state and not on the path. This is the seventh point, that is maximum work obtained from an isothermal process is a function only of the initial and final state and not on the path. Seventh, eighth statement, Planck's statement. Planck has given his statement regarding the that is second law of thermodynamics. So what is that statement? It is impossible to construct a device that will work in a complete cycle and convert heat into work without making any change in the surroundings. So this is the Planck's statement. It is impossible to construct a device that will work in a complete cycle and convert heat into work without making any change in the surrounding. Ninth statement, Thomson statement. Thomson has given his statement regarding the second law of thermodynamics. It is impossible to obtain a continuous supply of work by cooling a body to a temperature lower than that of coldest of its surrounding. So this is the Thomson statement. I will repeat again. It is impossible to obtain a continuous supply of work by cooling a body to a temperature lower than that of coldest of its surroundings. So these are the various statements of the second law of thermodynamics. So you have to remember at least 5 to 6 statements, because in the examination question is asked for 5 marks. Write different statements of second law of thermodynamics. So at least we have to write 5 points, 5 statement for that is the 5 points. So this is the statements of the second law. So remember that this thermodynamics second, it is theoretical topic and somewhat difficult as compared to that is the first law of thermodynamics. First law of thermodynamics is easy because various concepts we have seen in the 12th standard. So these are the repeated. Now next and important is the Carnot cycle. Carnot cycle. Carnot is a name of scientist. He has constructed a engine operating between that is a two temperature T1 and T2. So the name is given that is the Carnot cycle. So Carnot cycle. So Saudi Carnot is the name of scientist. Saudi Carnot constructed a engine operating between two temperature. It is used to demonstrate the maximum convertibility of heat into work. Carnot investigated the principle that governs the transformation of thermal energy into mechanical energy, that is heat into work. So this is regarding the introduction of Carnot cycle. That is, only remember Carnot is a name of scientist. He has constructed a engine operating between two temperature, that is a T1 and T2. Next is very important is the consider a cylinder which is fitted with weightless and frictionless piston. So we have to, the Carnot cycle work in 4 steps. So remember that, very important. We have to obtain the total work done in Carnot cycle. So remember that is Carnot cycle work in 4 steps. Carnot cycle work in 4 steps. So what are that 4 steps? First is isothermal expansion. Second is adiabatic expansion. Third is isothermal compression, and fourth one adiabatic compression. So remember these, that is the 4 steps of the Carnot cycle. So you remember that is Carnot cycle work in 4 steps. First is isothermal expansion. Second is adiabatic expansion. Third is isothermal compression, and fourth one is adiabatic compression. Now see the Carnot cycle work in 4 steps. So we have to obtain the work done in, total work done in Carnot cycle. हमें यहाँ पे आपको जो है Carnot cycle में total work done मालूम करना है. So you remember that Carnot cycle work in 4 steps. Isothermal expansion, that is shown by diagram. So this is the first, see the diagram, that is Carnot cycle. We have to obtain the work, the total work done in Carnot cycle. So it is very important. 10-mark question is asked on this bit. That is the obtain the total work done in Carnot cycle. So we have to, that is write first, that is Carnot cycle work in 4 steps. So what are that 4 steps? That is the isothermal expansion, then adiabatic expansion, then isothermal compression, and adiabatic compression. So see here, that is this Carnot cycle I have shown in diagram. That is, first is the isothermal, that is expansion. So first is converted into second, that is first to second, isothermal expansion. Second, adiabatic expansion. Third one, here is the isothermal compression. Third is converted into 4 into 1. It is converted into, that is the fourth one, that is adiabatic compression. So Carnot cycle work in 4 steps. We have seen isothermal expansion, adiabatic expansion, then isothermal compression, and fourth one adiabatic compression. Now see there, that is a work done in Carnot cycle. So that is very important here. That is you, whenever you writing the answer. So what is the question here? Obtain expression for total work done in Carnot cycle. So this is the question. So we have to write the Carnot cycle work in 4 steps. Carnot cycle work in 4 steps. So we have to write that 4 steps. First is isothermal expansion. Second is adiabatic expansion. Third is isothermal compression, and fourth is adiabatic compression. So we have to count or obtain the work done in each 4 steps. यानी आपको क्या करना है, हर स्टेप का वर्क डन कैलकुलेट करना है. दैट इज आइसोथर्मल एक्सपांशन है So we have to calculate the work done in isothermal, that is expansion, that is denoted by W1. Suppose we will see in detail later on. Then that is next is isothermal adiabatic expansion. So again we have to calculate the work done in adiabatic, that is expansion. That is we denote this work as W2. Now what is the third step? That is third step is that is isothermal compression. In isothermal compression we have to that is obtain work done, and that is denoted by that is the W3. And lastly that is adiabatic compression, and we have to obtain the work done in adiabatic compression, that is denoted by that is the W4. And what is the total work done in Carnot cycle? Addition of all these four states, that is we have obtained W1, that is isothermal work done in isothermal expansion, then W2 work done in that is the adiabatic expansion, W3 work done in that is the isothermal compression, and W4 that is the work done in that is adiabatic compression. And total work done is obtained by adding all these four, that is W1 plus W2 plus W3 plus W4. So if we add all these, then we can get that is the total work done. So it is somewhat big, so it does not complete today. So the remaining part of this we will be discussing the next period, because I think at 10:45 your physics period is there. Husseini sir has asked me to that is complete up to 10:40 or 10:45. Okay. ऐसा सुनाई दे रहा है?
Yes, sir.
Yes, sir.
Remaining part we will be discussed, but you give the test. Most of the student has not given the test. It can be given all the students. Remember that. So only one point is today's lecture is very important. That is the statements of the second law. So in the next period we obtain the work done, total work done in that is the Carnot cycle. If any difficulty is there, ask within the 2 minutes or write in the chat box. Is any problem?
No, sir.
चैट बॉक्स में क्या लिखा हुआ है? हमने बोले सर टाइम के ताल्लुक से है क्या? लेक्चर के टाइमिंग के ताल्लुक से?
जी सर, वो फिजिक्स का लेक्चर था।
अच्छा ठीक है। सर ने हुसैनी सर ने मुझे बताया था फिजिक्स का लेक्चर है 11:15 बजे, छोड़ दो आज का दिन बोल के, तो मैंने 10 मिनट पहले स्टॉप कर दिया।
जज़ाकल्लाह सर।
जज़ाकल्लाह सर।
नज़ा आपने मेरे ख्याल से टेस्ट नहीं दिए, मैं देखा वहाँ पे रिकॉर्ड।
जी सर आज देते।
हाँ वही मैं देखा।
जी सर आज इंशाल्लाह।
हाँ दीजिए, सभी लोग दीजिए, वहाँ पे स्टडी कीजिए पहले थोड़ा,
जी
उसके बाद दे सकते। ओके वी विल स्टॉप हियर।
जी सर।
ओके थैंक यू।